So welcome to Integrated 2, 2.1.1, Triangle Congruence Theorem. So this should be a review from last year, maybe the last 2 years actually. And I'm just going to go through and run through some markings on these pictures for you. That's normally how we see these. So if we have side, 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 triangle congruence, remember that you're going to have sides that match up based off of the markers, or you're going to be given enough information to say, oh yeah, okay, I know that those two are congruent to each other. Remember though, you want to make sure that the appropriate markings go together. So single tick mark goes with a single tick mark. Double goes with a double, and then a triple goes with a triple. Notice the only thing marked in the picture are sides. Okay, now we have side, angle, side, triangle congruence. With this one, you need to make sure that you're going to have two sides marked for sure. But the importance here, especially with the order, is making sure that the angle is going to be trapped between the two sides. Okay, now we've got angle, side, angle, so we have two angles marked this time. Making sure that the markers look different. And then same idea, you want to make sure that the side is trapped between the two angles themselves. Angle, angle, side. Okay, so we have two angles marked again, or have been identified as congruent somehow. And then the side could be different options. You just need to make sure that the way that you would trace over them would be the same between the two triangles. And you don't want the side to be trapped between. So in this case, it could be that the markers are there. That's one option. Another option would be those sides being marked. And then hypotenuse leg, although this one doesn't have three things in the name, it kind of does. It's just not as blatant. Hypotenuse has to come from a 90-degree triangle. So you absolutely must know that there is a box in the corner, and then the hypotenuse is always opposite that inside the triangle. So just the word alone, hypotenuse, actually gives you two pieces of information. And then the leg, you just need to make sure that, again, they match up. However, it doesn't have to be those two. It could be the other two. That's very possible. Okay, so here we have some examples, and we're not going to go out and do a full-blown proof just yet, although you and I are going to be doing that this chapter. We just want to be able to determine if the triangles are congruent or not. And if they are, you have to be able to justify why. So which one of those 5 reasons? So if we take a look at the very first one, I see two sides marked. So I'm just going to go ahead and do some color coding here. So those two sides match. I know that those two sides match. And then last, I know that the angle is going to match. And it looks like it's the angle in between. So congruent, I don't know, I think I'm going to figure out my reason first. So when I go through and do this, I typically just have my 5 triangle congruences written down, and I just kind of start marking them off. So if I take a look at my list here, based off of what's marked, I've got 2 sides and 1 angle. So I mark off the ones that I know it can't be. So 2 sides, 1 angle. Okay, so this is either side, angle, side, or is hypotenuse leg, if it's going to work at all. Well, it's not a 90-degree box in the corner, so I'm going to cross that out. Side, angle, side. Is the angle trapped between these two sides? Yeah, it is. So I'm going to go straight down to my reason first, and I'm going to put side, angle, side, triangle congruence. And then, yes, since it does satisfy it. And then the way that we name these, you just have to make sure that you follow the order. So we started at P, then went to Q. So go across the blue, land at the purple, and then go from Q to R, so go across the green. So it is, the order is blue, purple, green. So I just want to make sure that we do blue, purple, green. So in this case, it's going to be U, T, S. And make sure that you put a triangle marker in front of that so we know what symbol it is. Okay, taking a look at B, you want to make sure, at this point it doesn't look like we have enough information in it. However, we are going to use one of the things that we've done in the past, which was the idea of having 2 triangles kind of right next to each other. We have that side that is shared by both of them, which is this side right in the middle. So I'm going to go ahead and use a single tick mark on that one. Again, I'm not writing a full-blown proof, but I do want to make sure that I have enough information in the picture to even make a educated response. And then taking a look at the rest of this, Looks like I've got boxes in the corner down here. Okay, so taking a look at this, I've got two sides and one angle. So two sides, one angle. Okay, so this is either side angle side or HL or nothing. In this case, I do have a box in the corner, but you still need to take a look. We do know that the green side is a leg, so that takes care of it. So I guess the question is the blue side the hypotenuse? Which it is. If you take a look, hypotenuse is always marked opposite the box. So I do believe that what we have here is HL. So let's do our reason is HL, triangle congruence. And then follow your order. So WXZ, so blue, green, purple. So triangle, so blue, green, purple. It's going to be YXZ. And my reason would be yes. Just see if you can do the next one. Okay, so here on part C, I went through and I color-coded the stuff just like I had done previously. But in this case, I only have angles, and none of the relationships only have angles. So my answer is just no. And then reading the directions says, if no, circle no and move on to the next problem. Okay, so moving on, one of the things that we're going to be doing new this year for you guys is the idea of kind of continuing our proofs with not only being able to prove triangles themselves, but being able to prove parts of triangles. So we have these congruent triangles give congruent parts. So if the triangles are congruent, so that means that all the corresponding angles match and all the corresponding sides match, then that means that everything else matches. So let's say hypothetically that you have side, side, side matched up. So you've got these triangles that we know are going to match. And side, side, side was already given to you, or you already proved side, side, side. So you've satisfied one of the 5. If the triangles are in fact congruent to each other, then that means that all of the other parts, so all of the other angles that you either haven't matched up or all of the other sides that you haven't matched up are going to have to be congruent as well. So we know that between the single and the double is going to have to match. Why? Because we have congruent triangles, and now their corresponding parts are going to match up as well. We have between the single and the triple for the exact same reason. So if we already got to be able to prove that the triangles are congruent, then that means that everything else that should match will match. Now, there's a couple of ways that we can write this out. You can say congruent triangles give congruent parts, or there's the shorthand version of CPCTC, where it's a direct pull straight from corresponding parts of congruent triangles are congruent. It's kind of a mouthful. I'm not a big fan of CPCTC only because, actually a couple reasons. One, people don't know what it means. So they just plop it down as a explanation without any real understanding of it. Then if you're going to use it, you have to make sure that you're using it correctly. And because people don't really understand what it is, they put it in the wrong place in a proof sometimes, and they mess up the order of the CPCTC. So just be careful how you do this. So, and then a couple other things too. We've got the reflexive property, which you guys learned or used last year. So reflexive property can look a couple of different ways. It can look like a shared side. So it's a side that belongs to both of them. That's what we use when we talk about congruent triangles. One of the other things that we talk about though too is triangles. So when we talk about similarity, this is another type of a situation where you technically have a little triangle kind of inside the big triangle. So if we color code these. So here's our small triangle sitting inside the other large triangle. So small triangle sitting inside the large red triangle. If you take a look, there is a common angle that belongs to both of these. That common angle is going to be this bottom corner in blue. That's also reflexive. We're going to use that later when it comes to proving that triangles are similar to each other, not congruent. And then we have some more algebraic properties that we normally do. So you have the symmetric property. So if we take a look at this, if A is congruent to B, then we say that B is congruent to A. So it's kind of like 7 is equal to 5 plus 2. Okay, 5 plus 2 is equal to 7. It doesn't really look all that spectacular. The transitive property, this is one I know that you definitely used, man, it was a couple years ago. So if A is equal to B and B is equal to C. All right, so I like using numbers for this. So if 4 is equal to 3 plus 1, and 3 plus 1 is equal to 6 minus 2, you kind of get rid of the thing that linked these together. So the 3 plus 1 is what belongs in both of them. Then we can say, so this implies that the beginning of where you started is equal to the end, which we know that 4 is equal to 6 minus 2. So you kind of cut out the middleman. That's what I think of whenever I think of the transitive property. And then one more definition too. Pretty straightforward though. If you have two things that are the exact same measurement, so if we were to have two triangles here. So let's say we have one triangle and we have another triangle. And we know that, let's say that's angle A and that is angle B. If they're both identified with 90 degrees, then we would say, okay, the measure of A is 90 degrees given. We had a box in the corner. Then we would also say that the measure of B is 90 degrees given. We had a box in the corner. If they're both the exact same measure, then we can say that the two angles, so the shapes themselves, are congruent, and that is the definition of congruence. And I think that settles it for this one.